Hello friends, welcome you all on the TCS NQT Coding session. Good evening Shubham. First of all, we'll check the audio visuals. First, if I'm audible to all of you, please press 1 so we can understand. Please press 1 if I'm audible. Please press 1. Okay, Shubham has joined. Shubham, good evening. Okay, rest of the people are coming. Good evening Aneri. Please press 1. Okay. So is the board is visible? Board is visible. I'll write something, so please tell me if it is visible or not. If it is visible, just press 2. If whatever I have written on the board is visible or not, I'll write TCS. Is it visible? Please press 2 if it is visible. Is it visible? If not, press 3 so you can understand. We'll change the brightness of the camera. Please check. Okay, so I think we are done with the all the audio visuals. Okay, we'll start. So today we are going to see one more problem in the TCS NQT coding session. Up till now we have seen different kinds of problems where we have generated the logic, and after generating the logic we have implemented that logic in our own C language code. Okay, there are different preferable language as per we have discussed previously. You can use C, C++, Perl, Python, Java. So you have the liberty to choose your preferable language. Okay, so we'll see today's small amount of seafood. First of all, I'll go with some PPTs so that those who have joined this session first time, they will understand what is the criteria and how the TCS NQT is going to be happen. Okay, so there are some instructions. You will getting 30 minutes. Choice of language is as shown in the screen, and the ID will be provided from the TCS end. Okay, there are some points. I'm not going to repeat it again. We have previously seen this in previous sessions. So these are the some points to note that you have to keep in your mind while programming in the TCS NQT session. Okay, so we'll see one small seafood that series we have started in last session, that is some seafood for your brain. So it's a small task. I have not given any choices for you. We'll just see what is the answer of this program. See, so small program, just a MCQ type program. Just give it as what is the answer, what is your preferable answer. I'll read the code for you. One variable x is uh, considered, which is of integer type. Then one for loop is used, which is moving from x is equal to 1 to 10, where x is incremented by 1. If x is less than 5, continue, else break, and after that printf statement is given abc. So the question is, how many times this abc will be printed? Okay, small question. How many times this abc will be printed? Just think over it for 2 minutes and give me the answer. We'll see in the comment box what is the answer you are considering. Just look at the question. You want to identify by looking at the program how many times ABC will be printed on the output console. Okay, all of you got the question? Should I repeat it? One code is written where, okay, Sneha has given as 4 times. Okay, we'll see one more minute. Just execute the program line by line. We'll call it as a dry run. Okay, Shubham is telling 10 times and there is saying 4 times. Okay, So these kind of questions will come in C MCQs. So you should be prepared for all these kind of questions before going to coding session. Okay, that kind of C questions will be, C MCQ questions will be asked. Okay, now also it's 6. You will see how many times ABC will be printed. Okay, I'll tell you the answer. Actually, if we'll see the program, we'll see the program first. In the program, you can see there is one, please Ajay, program. In program, we'll see what is given for x is equal to 1, x is less than or equal to 10. So in the first case, when x is equal to 1, it will go inside the loop if x is less than 5. So this condition is true when x is equal to 1. After that, the continue statement is used. So what will happen because of this continue statement? Because of this continue statement, the control will go to again for loop and x will be incremented by 1. Okay, the rest of the part will not execute. So x will become 2, 3, 4 up to 5. So at 5, when x is less than 5, it is equal to 5. So this condition will not be true. So it will go to else loop. After else loop, their break is given. So printf statement is not executing at least one times. If we'll give after break there will be one semicolon, it might happen that it may get printed at least one time. But here the curly brackets are not given. Okay, so as per the, you can use this code, just type this code in your whatever ID you are available with and see the output. You will get 0 times. Okay, so that is the output. Okay, got the answer. So there will not any printing of ABC. Okay, you just try this. Just take this as a homework or a task to see whether the output is 0 times, 4 times, 6 times, whatever it may be, whatever answer you are giving. Okay, so try to run the code with a dry run. Okay, what is a dry run? You have to execute the code in your mind line by line so that you can understand what is happening at each and every line and how the output will be printed. Okay, now we'll move towards our today's problem, today's coding session problem, that is write a program to print Armstrong numbers in the given range. So what is Armstrong number? We'll take one example. What is Armstrong number? If I have one example, it is 153. Okay, so 153 is Armstrong number. Is it visible? I'll use black. Why this 153 is called as Armstrong number? I'll tell you. What is the cube of 1? 1 cube plus 5 cube plus 3 cube. Sorry, 3 cube. We'll identify 1 cube is 1, 5 cube is 125 plus 3 cube is 27. Okay, so we'll add this, we'll get the answer as 153. So 153. So what is the concept? If the addition of each and every digit's cube is equal to the number itself, then that number is called as an Armstrong number. Then that number is called as a Armstrong number. So we have to write a program where the range will be given, and you want to identify all the Armstrong numbers within that range. Okay, we'll take one more example. 125. Is this Armstrong number? We'll check it out. 1 cube plus 2 cube plus 5 cube. So what is the 1 cube? 1 plus 8 plus 125. So obviously this is not equal to 125. It will become 126 plus 125 plus 9. So it will become 134. Okay, so these are not equal. That means this 125 is not a Armstrong number. This is not a Armstrong number. So if a range is given, what is asked in the question? In the given range. In the given range. So we'll consider two variables. One is start variable and one is end variable. Okay. So we'll consider some variables that we are required for this program. Integer, start. Okay. and then end. We'll use this start and end. These are the two variables. Okay, so these should be user defined. So obviously you have to take these values from the scanf. First of all, the message should be print like printf enter start, then scanf in double quote %d comma ampersand start. Okay, in that way we are going to take these values from the user. So start and end. After that, for example, we are starting with 1. Suppose the number is starting with 1 and suppose I'm ending it 1000. Okay, now what is the available values in start variable and end variable? Start is having 1, end is having 1000. Clear? Okay, then we'll see how to identify the number. So the number should be within this range 1 to 1000. So we have to start from 1, we have to end up to 1000. So one variable will take, that is num. That is a number variable. Okay. Then we are going to check whether the addition of cubes of each and every digit is equal to the number or not. Okay. So for that we'll use some more variables. First of all, I will tell you how we are going to identify this each and every terms. Suppose we are considering a 153. We are considering number 153. So I have to take this 3 out of this number. I have to take this 3 out of this number. So what I'll do, I'll take mod operator with 10. Mod operator with 10. So what will happen because of this mod operator? The remainder will be obtained. We'll get the remainder. So remainder, how much is the remainder? Remainder is 3. Remainder is 3. So I can use this 3 in cube form. After that, I'll take this 153 divide by 10. 153 divided by 10. So what is the answer? Answer will be 15. Okay. So again, I'll use a for loop. For this, I'll again use mod 10. So I'll get this 5 digit out of it. Okay. So in this way, we'll identify each and every digit from that number. Okay. And then we'll take the cube and we'll add into one variable. So for that, we'll use one variable remainder to identify the remainder value. Remainder is one variable. Okay. Then next is sum. For sum, we'll use one variable. Okay. And one temporary variable will be used because we are going to check whether the number is equal to sum or not. So whatever changes we are making, we'll make it in temporary variable. We'll make it in temporary variable. Okay. All of you got the question? We'll see some comments. Have you got the understand? Okay. Sum of cube of elements equal to number. Right. So that right. So all of you got the question? What we have to do? We have to make a program like this where the Armstrong number should be printed at the output console within the given range. If you have got understood, just press 1. So I can go for the coding part. Okay, all of you understood? What is the question? What is the Armstrong number? So 153 is the Armstrong number. The other numbers will check from 1 to 1000. Okay, all of you got the question? Please press 1. If you understood the question, please press 1. So I can go forward. Okay, I think all of you got the question. We'll move forward. Okay, good. So these are the variables that we have considered. Okay, so we'll move forward. Now we'll see, I'm not writing the program as it is. We'll see it in the online compiler, but I'm telling you the logic here. Okay, so we'll use one for loop. For here, the number will start. The number will start from start variable. Okay, and number is less than or equal to end. Okay, and number plus plus. This is the for loop. So that we can vary the number from start to end. Okay, in this way we are going to make it. After that, we'll take one variable sum and we'll initialize it to 0. First of all, we'll make it as 0. We'll use one temporary variable, and in that temporary variable, we are going to put this number. Okay, I'll tell you why we are using this temporary number. Now, we'll use one while loop. While temp is not equal to 0. So up to what time this while loop will work? Until unless this temp is not equal to 0. Okay, so we'll put this in curly bracket in temporary variable. So first of all, what we have to do? We have to identify the remainder. Okay, so we'll identify the remainder is equal to temp mod 10. Temp mod 10. So what will happen? Because of this value, we'll get the remainder out of it. After that, we'll use sum is equal to sum plus. Now that is a cube of r. So we'll use remainder cube. Remainder cube. Okay, so what we are doing? We are in sum. We are adding the sum plus cube of this remainder. Okay. After that, what we are going to do? By using this remainder, we can update this sum. Okay. Just we'll check comments if you got the output or not. Please let me check. Okay, we'll do one thing. If it is not that much clear, we'll go for our coding platform, that is online GDB, where we can see how this can be happened at each and every level. Okay, so we'll use online GDB's platform where I can tell you how it iterates at each and every point. Okay, because it's a little bit difficult here to explain each and every step. So we'll go for the online GDB's platform where the code has been written. Okay, please online GDB's platform. We'll see each and every example. So how it will work for some other number and for Armstrong number. Okay, we'll is it visible? All of you. Just a minute, I'll tell you. Okay, please press 1 if it is visible. Okay, is it visible? So see, I'll explain here only, so you'll understand what is happening at each and every step. As per we have discussed, we have considered these variables num, remainder, temporary, sum, start and end. Okay, so we are taking these variables. See, so by using scanf, we have taken the values start and end. Okay, so these are the values start and end available in the variable start and end. Okay, so here for example, if we are considering from 1 to 1000, first of all I'll run this program so you can understand how the output should be look like. Okay, we'll see how the output will be so you can get the clear idea what we have to do. Okay, 1 is the start number, 1000 is the end number. Okay, look at the output. So in the 1 to 1000, these are the Armstrong numbers. So 1, 153, 370, 371 and 407. So this kind of output should be printed at the output console. So that is our task. Okay. So we'll see how this thing is executing. Okay. We'll see it in how this thing is executing one by one. So we have considered a for loop. We have initialized sum is equal to 0. Okay, then temp is equal to num. After that, we have considered one while loop where temp is not equal to 0. One while loop has been used where temp is not equal to 0. Then we have identified the remainder. Okay, after that, by using that remainder we have used cube, remainder cube in the next line. And see, we'll take one example here so that you will understand this. We'll consider a number 153. Okay, so what will happen with 153? It will start from this location. Okay, so suppose by using this loop we have started from 1, we have gone, end is 1000, in between we have come up to 153. Okay, so we'll see what is happening at 153. Sum is 0. Okay, then in temporary variable the number will be come. So your temporary variable is now 153. Okay, so this condition will be checked while temp is not equal to 0. So 153 is not equal to 0. So it will go inside this loop. So remainder is equal to temp mod 10. So what is the remainder here? As we have discussed in the on board, 3 will be the remainder. Okay. So next step, what will happen? Sum is equal to sum plus remainder cube. So here we have got remainder is equal to 3. Already we have initialized sum is equal to 0. So this will become 0, and previously this sum is also having 0. So whatever cube value of remainder will obtain in this sum. So 3 cube. What is 3 cube? That is 27. So in sum variable, now after this one iteration, it will be having 27. After that, temp is equal to temp by 10. 153 divided by 10. So this temp variable will be modified. Now it will become 15 because 153 divided by 10, it will become 15. So again the condition will check whether this 15 is not equal to 0. This condition is true. Yes. Will come again here. So remainder is equal to temp mod 10. So 15 mod 10. What is the output? Mod 10, 5. Okay. And sum, this variable will be modified. Previously the sum was 27. Now 27 plus 5 cube. What is 5 cube? That is 125. So 125 plus 27. So it will become 133. Okay. Again this 15 is available in temp. So temp is equal to 15 divided by 10. So what is the answer? 1. It will go again up. Whether this 1 is not equal to 0? Yes, this condition is right. So we will identify the remainder. So 1 mod 10. What is the remainder? 1. So sum is equal to 133 plus 1 cube. So this will become 1. So 133 plus 152 plus this 1. So 153. Okay. So in this way this loop will execute. So when first iteration happened, we have got 27. In second iteration we have got 125 plus 27, which is 152, and in the third iteration that 1 will be added and it will become 153. After that this condition will be checked whether this sum is equal to number. Yes, 153 is equal to 153, so that we have to print this. Okay, so in this way this loop will execute. But if it is not Armstrong number, if it is 125, this condition will not be satisfied, as we have discussed in previous case. When we have taken 125, what is the output? In 125 the total 1 cube plus 2 cube is 8. So 1 plus 8 is 9. 9 plus 125, that will become 134. Okay, so this condition will not satisfy for 125 number. Okay, and it will go on for loop. So number will be incremented. So this for loop will work for 1000 times. Start from 1 and it will end up to this 1000. Okay, we'll run this program once again. We'll see within 2000, 1 to 2000. Suppose we'll give start value 1 and the end value is 2000. Okay, so within this range we are getting all the Armstrong numbers. what will happen if we are starting with 2 instead of 1? If we'll start with 2, okay, I'll take the input as 2 and we'll take 1000. Okay, so if you'll see, 1 is not printed here. We have started from 2, so this for loop is worked from 2 to 1000. So 1 is not included, so 1 is not printed at the output. So only 4 numbers are in between 2 to 1000. Okay, all of you got the logic? If you have any doubts, please ask me. We'll see in the comment box if someone is having any doubts. Okay, Mr. Audi, can you please say what's the correct to learn web designing and the time complexity is increased here? Yeah, actually it depends on each and every one how you are building your logic. See, I have written this program as per my logic. You can implement this by using your logic also. Okay, it's not mandatory to go with this way. I'm just sharing you what kind of problems can be asked, and you have to solve these problems within 30 minutes. So you have to keep all the constraints in your mind. See, making the that means making the problem optimized is not our current task. We have to get the output within 30 minutes. That is our main motto. Okay, here we are not going to show what kind of optimization we can do and all that. Okay, so it will require some more time, but what is required, we have to get correct output within this 30 minutes time. Okay, so you have to use that 30 minutes wisely so that you can check each and every test case. Okay, so we'll stop today's session. If you have any queries, just please let us know so we can solve that kind of problems. If you have any doubts or queries, please share it on Shikuya's app so we can identify that kind of problems and we'll try to solve it. Okay, so don't forget to like this video, subscribe to our channel and follow us on Instagram, Facebook and LinkedIn. Thank you. Thanks a lot.